you always want to look for a GCF. So, is there something that both of these terms have in common? They both have an x. So we're going to factor out the GCF. So I'm going to get an x, which leaves me with x squared plus 1. So what's in the parentheses? Look at that and see if it fits either of these. What do you think? We don't have a sum of squares. These both are perfect squares, but there's nothing that actually we can do with a plus sign. And it's not a sum of cubes because this would have to have an exponent that's a multiple of 3. So it actually cannot be broken down any farther. So actually we're done factoring on this one. So once we factor completely, we take each factor, your GCF, if your GCF has an x in it, that counts as one of your factors, and we set it equal to 0. So we have x equals 0 and x squared plus 1 equals 0. Oh, there's nothing else to do there. But on this one, you need to subtract 1 from both sides. And then what? Square root. What is the square root of negative 1i? And try to remember to put the plus or minus in the front. This one was not so bad. All right, number 2. Notice it's not set equal to 0. So we've got to subtract 3x squared from both sides. To get it set equal to 0. And that gives us 4x cubed minus 10x squared. Is there a GCF? 2x squared. So they both can be divided by 2, and I can take x squared from both of them. So I'm left with what? 2x minus 5. Now look in the parentheses. Is that a difference of squares? No, 5's not, 2's not a perfect square. What about cubes? No. So it doesn't fit any of our other factoring methods. So we're done factoring. So now we got to set each factor equal to 0. And this first one, what do I get if I divide by 2? 0. What do I get if I take the square root? 0. And the second one, we need to add 5. And then divide by 2. If you put 2.5, that's okay. Or 5/2. Any questions? Okay. Number 3, it is set equal to 0. Is there a GCF? Are you sure? X. So I'm going to take out an X from each term, leaving me with x squared minus 8x plus 16. Now let's look at what's in parentheses. It is 3 terms. It's a trinomial. So it's not guaranteed that it will factor down, but most of the time it does. Is there anything that multiplies to be 16 and adds to be negative 8? Yep. Negative 4 and negative 4. Now, in my parentheses, is it going to be x minus 4 or x squared minus 4? Just x. We use an x squared if my problem is x to the 4th, x squared. Kind of matches whatever the middle one is. So x minus 4, x minus 4. So now I'm ready to set my factors equal to 0. Since I have 2 of the same factors, you don't have to write it out twice, but what you might see is, we talked about this a long time ago, multiplicity of 2, which means I had that factor 2 times. So that's a multiplicity of 2. And if you remember, that means if I look at the graph, we talked about the graph bouncing or crossing. If the multiplicity is even, it's going to bounce at that x-intercept. Let's look at number 4. Is there a GCF? What is it? 2x to the 2nd. That leaves me with x to the 4th minus, we're dividing, so it'll be 5x squared minus 24. This is a trinomial. So we want to see if there are 2 numbers that multiply to be negative 24 and add to be negative 5. Are there 2 numbers?
Negative 8 and 3.
Yep. We have a negative 8 and a positive 3. Am I going to put an x or x squareds in these? X squareds.
Do you know that if it's like in the middle?
Yeah. If you have x to the 4th and x squared, you're going to have x squareds. If you have x to the 6th and x cubed, you would have x cubes, which we didn't do any of those. But all right, now let's look at what's in the parentheses. Is this a difference of squares? Is 8 a perfect square? It's not. So it's not a difference of squares. What about a difference of cubes?
No.
Your exponent's not a multiple of 3. So, yeah, I had some in here to throw you off. This is neither. It's nothing. X squared minus 8 is not a difference of squares. It's not a difference of cubes. X squared plus 3, that could only be a sum of cubes. It's not that either. So there's actually no more factoring that we can do here. So we're going to set each of them equal to 0. And we know that this is equal to 0. We already did that. Okay, so if I add 8, yeah. So we have x squared equals 8. I've got to take the square root. But is that a perfect square? No. So we got to split it up. What is the largest perfect square that goes into 8? 4. 4 times 2 is 8. And we know that the square root of 4 is what? 2. So my answer, we're going to do plus or minus. Anytime we take the square root, try to remember to put plus or minus 2, and then I have this square root of 2 left over. And then my third factor, x squared plus 3 equals 0. What should I do first? Subtract 3. And then take the square root. All right. So it is negative. So we have to break it down. We got to get that negative 1. And then we're left with positive 3. Can you divide 3 by any perfect squares other than 1? No, you can't. So if that happens, we just don't break it down. We just leave it as square root of 3. But what is the square root of negative 1? I. So my answer is plus or minus I square root of 3. We're only doing 3 more. Number 5. Is there a GCF? No. Okay. It's 2 terms. So do we have perfect squares or perfect cubes? It's a difference of squares. Now, 64 is a perfect square and a perfect cube. So, but if I base it on my exponent, that exponent is a multiple of 2, which means it's a perfect square. So we're going to do difference of squares. So what's the square root of x to the 4th?
X to the 2nd.
Plus 8 squared minus 8. Now let's look to see if we have either of our factoring. This is a plus sign, so the only thing it could be is a sum of cubes. Is it a sum of cubes? No. The 8 is a perfect cube, but we had this one before. The x squared is not a perfect cube. This one, it is a difference. We have an x squared, but 8 is not a perfect square. So it cannot be broken down any. So we're ready to set each one equal to 0. If I subtract 8, I get x squared equals negative 8. And then I take the square root. I've got to have the negative 1. And then we did this, we know it's 4 and 2. Square root of 4, square root of 2. Okay. And we know the square root of -1 is I. The square root of 4 is 2. That last one just stays. So x equals plus or minus 2i square root of 2. And then we have x squared minus 8 equals 0, which we did on the previous page. It's going to be the same thing as this one, just without the I, because it just doesn't have a negative. So you don't have to write all that out. Any questions? All right, number 6. Do I have a GCF?
Yes.
What is it?
5.
5x. They're both divisible by 5, and they both have at least an x. So that leaves me with x to the 4th minus 16. Is this one of our things? It's a difference of squares. And so I'm just gonna, your GCF, some of you on the quiz that you all took yesterday, you forgot to bring down your GCF. So your GCF always has to get brought down. And then in my parentheses, what's the square root of x to the 4th? X to the 2nd. And what's the square root of 16? 4. Okay. Every time you do this, you look at the parentheses to see if something can be done again. Do we have something that can be factored more? The second one, what is that? This is also a difference of squares. I know that because it's subtracting. X squared is a perfect square. 4 is a perfect square. So what's the square root of x squared? X. Square root of 4? 2. So I have a plus 2 and a minus 2. Now, can any of those be factored down again? No.
Why do we not do some squares?
It just doesn't work out that way.
Wow.
If I, like, let me give you an example. If I have, like, x plus 3 and x minus 3, okay, that would be x squared minus 3x plus 3x minus 9. And those cancel. So we get x squared minus 9. Okay. What if I tried to do it x plus 3, x plus 3? That's a sum. We would have x squared. That would be a plus 3x. That's a plus 3x. And that's a plus 9. The issue here is that these don't cancel out. This turns into 6x. So you can't, there's no way you can manipulate that to get an x squared plus 9. So if we take each factor and set it equal to 0, we have 5x equals 0. So x equals 0. 0 divided by 5 is 0. We have x squared plus 4 equals 0. So if I subtract 4, and then take the square root, I have a -1 and a 4. The square root of -1 is I. 4 is the perfect square. What's the square root of 4? 2. So my answer is plus or minus 2i. And then we have x plus 2 equals 0. So x equals -2. And x minus 2 equals 0. So x equals positive 2. Questions? Let's do number 7. Is there a GCF among all 4 terms? No. So there are 4 terms, which means we have to do grouping. And so I'm going to take the first 2. And I'm going to take the second 2 and kind of split them up. And I have to find the GCF of each group. So what is the GCF of the first group? X squared. Leaving me with 2x minus 3. Good. What would be the GCF of the second group? Not 12, not 8, not 6. Look, you know this needs to be 2x minus 3. So what? Yeah, it's actually going to be -16. Since your first one is negative, your GCF needs to be negative. And if I do take -32 divided by -16, it's 2. 48 divided by -16 is -3. And so my factors, we take the outsides, x squared minus 16, and the insides, 2x minus 3. Yep. This x squared minus 16, and recognize them. This is a difference of squares. And what's the square root of x squared? X. Square root of 16? So we have x to the 4th, or x plus 4, x minus 4. And that's all of our factors. Nothing else can be factored down. So set them equal to 0. Now, I did say we would stop there, but I changed my mind. We're going to do one more, but we're not going to work through the whole thing, and I'll show you why. But none of the ones we did involved the cubes. And I'm not going to give you any of those. But I do want to do one just so we can practice factoring it in case you need that help. The reason we're not going to solve it all the way through is because it requires the quadratic formula. And I'm not going to have you do any of that. So number 9 is x cubed plus 125. Is there a GCF? No. So what method is it? What factoring method? Sum of cubes. 125 is a perfect cube, and then anything with an exponent that's a multiple of 3. So for the cubes, it kind of helps to write all of this out. These are all 5 pieces from the formula that you were given. And so your A, you're going to take the cube root of each side. So what's the cube root of x cubed? X. What's the cube root of 125? 5. And so then if I do A squared, that's x squared. What's AB? 5x. You're multiplying. X times 5 is 5x. And then B squared, yep, 25. Right. And your formula for a sum of cubes is A plus B, so x plus 5, and then x squared minus 5x plus 25. Now, the reason this is quadratic formula, is there anything that multiplies to be 25 that adds to be negative 5? No, 1 and 25, 5 and 5. Anytime you have a sum of cubes, that's what would happen over here, or difference of cubes. It would require the quadratic formula. We're not going to do any of those. Okay, but I did just want to practice factoring the cubes. Okay, so we will stop there.